Hi, this is Chris, and we are taking a look at 26 through 28 here in Section 4 of SAT Practice Test 3. So for question 26, it says, in the XY plane, the line determined by the points 2K and K32 passes through the origin. And a lot of times it's very easy, especially under the timed pressure of an SAT, to overlook the fact that when they say it's the origin, that means they're giving us a coordinate. The coordinate of the origin is 0, 0. And the reason that that's important is because a lot of times, if they give us an extra coordinate, we can do a lot in terms of solving the question. And in this case, if these are all on the same line, it says the line, then that means that the slope between this point and this point and this point, any combination of those 2 points has to give us the same slope. So let's think of how we calculate slope. So when you calculate slope, your slope equation is going to be that m equals y2 minus y1 over x2 minus x1. So let's see if we can apply that to some of these coordinates. That means if I look at this point here, and I compare that to the origin, k minus 0 over 2 minus 0, that'll be the slope between those 2 points. And that also has to equal, because again, all these points are on the same line, that also has to equal the slope between those other 2 points, which would be 32 minus 0 over k minus 0 for those 2 coordinates. And now we have enough that we can simplify, rearrange, and solve for k, which is what they're asking for. They want to know the value of k. So here, the minus zeros we can ignore. That simplifies to k over 2 equals 32 over k. Cross multiply, k squared equals 64. And take the square root of both sides. K equals 8 will be our correct answer here on 26. So although that's a pretty difficult question if we're moving through quickly, especially late in the section, as long as we recognize that the origin gives us this coordinate of 0, 0, we can use this concept of collinear points to set the slopes of any 2 of those points equal to each other and get our result for k there. Now we'll take a look at 27. It says a rectangle is altered by increasing its length by 10% and decreasing its width by p%. So here, if we were to try to find a value for p, it's hard to do with just one equation because we only have one equation with one variable in terms of a relationship. But let's see if they give us additional information. If these alterations decrease the area of the rectangle by 12%, okay, so now we have a second piece of information. Increasing length by 10, decreasing width by p, and then they're telling us the impact on the area. Decrease the area by 12. What is the value of p? So since they're looking for p, and they give us options in our answer choices, let's see if we could test out some of those options. So let's try A. It's always helpful to use your answer choices to your advantage. If A is 12, then if you increase your length by 10, so that basically means that your new length increased by 10%, that's the equivalent of saying that you're going to multiply by 110%, or multiply by 1.1. So if we decrease the width by p%, that means that for answer choice A, if we're decreasing by 12%, that means it's 100% minus 12%, which would be 88%, or we'd be multiplying by 0.88. And let's see if that means that we would be decreasing the area of the rectangle by 12. Well, here, I know that for my area, and I'll put that right up at the top, but your area is going to be your length times your width. And so here, from your original area, if my new area is going to be, we'll call it A new, 1.1 L times 0.88 W And let's resize this a little bit, see if we can move this over. But when I multiply that, I probably don't even have to do the calculation, because I know that my final area is supposed to be 12% less, which means my final area is supposed to be 88% of the original. And if I do 1.1 times 0.88, I'm going to end up with 0.968 LW, which is equivalent to saying 96.8% of my original area, or a decrease of merely 3.2%. So A doesn't work out for this one. We're going to have a greater value for P to indicate a greater decrease in our width to match this. But let's use this structure and then test out our other answer choices with those same calculations, but with a different value. So for answer choice B, we're going to do 15. So our new area here would be the same 1.1 times the length, because that's not changing for any question. But now, if we decrease the width by 15%, that's like multiplying by 0.85. And let's see what that would give us compared to our original area. So 1.1 times 0.85 is going to give us 0.935, or 93.5% of our original. So that's a decrease of about 6.5%, but still not enough. Let's test out answer choice C here. Our new area, again, the change to the length is not changing for any of these. That's always a 10% change. And then if we now have a width that was decreased by 20, that's like saying we're multiplying it by 0.80. And when we multiply that out, 0.8 times 1.1, well, guess what? That comes out to 0.88 of our original. And I'll throw in the LW up here just so we can see it in both places, which is in fact 88% of our original area, which does reflect a 12% decrease, which is what we're targeting in this question. Our correct answer on this is going to be answer choice C. Now let's take a look at 28. In planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. So let's start with that, and let's use the principle that we just looked at in question 27, which is a decrease of 10%. Remember, every percent change that you have is always relative to 100%. So a decrease of 10% means that your remaining amount would be 90% of your original, which is equivalent to saying that you're multiplying it in decimal form by 0.90. So with that alone, we can confidently eliminate A and B on this. And here we have to then look at, are we taking that 20 and multiplying it times t, or dividing t by 20? Well, this percent decrease happens every 20 years, which means that if t equals 20, that we should have this percent change take place just one time. It happens once every 20 years. So here, when you plug in a 20 for t, you should get, for your exponent, a value of 1, that you're multiplying by 0.9, or 90%, just one time, because it's one change every 20 years. So when they say every 20 years, that's their way of letting us know that we will be, for our exponent, dividing by 20 in this question, which is answer choice D. And 28's a great example of a really tough question that we can actually answer very quickly if we understand this concept here about percent change and what calculation we need to do in order to end up with that remaining amount. We can eliminate A and B quickly, and then in identifying the correct exponent, we see that once every 20, or once per 20, is the equivalent of saying that we have t over 20. That's our exponent, and that matches answer choice D. We'll finish.